Hello guys, welcome to Crown Smart. In this video we're going to talk about domain of what functions. Now normally how we define domain is simply the set of values which makes a function to be what defined, or the set of input which has an output giving what a function. Now here we have to find the domain of the following functions. Okay, so now we have from here we have 1 to 6 functions here. So the first two functions, although they are algebraic functions, okay, also known as polynomial. Now if for a polynomial function in general, a polynomial function, the domain of a polynomial function is all real numbers. Now observe that for any value of x I put here, I will have a corresponding value of what? F of x. Okay, so if I have f of x to be 1, if I have x to be 1, sorry, my f of x will be f of 1 is equal to 2 brackets 1 plus 3. So I have here as 2 plus 3, which is 5. So for any value I get, I always have what? An output. So it means that these two questions, the domain of this is all real what? All real number. So in general, all polynomial function, the domain of it is all real numbers. Now secondly, we are going to go to this function. This is a very interesting function. Now we have assuming we have a case, let's say 1 over y. Now at y equal to 0, observe that 1 over 0 is infinity, which is undefined. So we want to set a case where x squared plus x is not equal to 0. So what we do is to set x squared plus x not equal to 0. Now this implies that x by factorization, x plus 1 is not equal to what? 0. So this means that x is not equal to 0, or x plus 1 is not equal to what? 0. So solving this one, we have that x is not equal to minus 1. Now let's sketch this. If we have this as 0, we have this as minus 1, we have this as minus infinity, we have this as infinity. We can see from here to here, here to here, and here to here, we have about 1, 2, 3 intervals. Okay, now we want to test this interval. By testing this interval, what it means is that if I pick one value from here and it is true for this value, definitely it's true for every other value in between it. So what we're going to do, we're going to test this. So now let's check the value between minus infinity and minus 1. We have minus 2. Now if I put minus 2 here, I'm going to have 1 over 4 minus 2, which I'm going to have is 1 over what? 2. So you see, it satisfies this value. Now between 1 and 0, what do we have? We have between minus 1 and 0, we have minus 0.5. So if I put minus 0.5, it is seen that we can also have what? A value. And between 0 and infinity, observe that if I put a value 1, okay, I have this as 1 square, 1 over 1 square, which is 1, plus 1, which is 1 over 2. So you see, I still have a value. So it is true for every other value between it except minus 1 and what? 0. So the domain for this function is minus infinity to minus 1 comma union minus 1 to what? 0 open brackets, we close it at this, not close, actually it's still open here, union, we have this from 0 to infinity. So this is actually the domain for this what? For this function. Now next we are going to find the domain for the function root function. Now the function here, we have it as the square root of x minus 1. Watch, now we have the square root of x minus 1. Now to find the domain for this function, remember square root function, let's say we have square root of y. Now for this square root function, for this function to have a value, for z to have a value, y must either be 0 or y must be greater than 1. So we set x minus 1 to be greater than or equal to 0. So this implies that x is greater than or equal to what? 1. So if we draw this, we have this as 1 is infinity, this is minus infinity. So from our inequality, we know that x is greater than 1 means x is greater than or equal to 1. It's talking about values in this point. Now including including 1. Okay, so now if we pick values from here, let's pick 2. Okay, if we pick 2, we have that 2 minus 1 will give us 1, so square root of it is what? 1. So it's defined, so it means that since it's true for 1, it's true for all of them. So the domain for this function is actually 1 to what? Infinity. 1 included to what? Infinity. Now the next one is to find the domain for another square root function, which is the square root of 4 minus x squared. Okay, this is very interesting. So with same rule, we set 4 minus x squared to be greater than or equal to 0. Now setting this to be greater than or equal to 0, we have that minus x squared is greater than or equal to what? Minus 4. Multiply both sides by minus 1. I have that x squared is less than or equal to what? 4. Now x is less than or equal to plus or minus what? Square root of 4. X is less than or equal to plus or minus 2. Now from here I have that x is less than or equal to plus or minus 2, so I have this as minus 2 and I have this as 2. Okay, now these are the values here. So we have created an interval. Now we are going to test these values to see if this is true. Now if I pick a value from here, let us say minus 3, and I impute it here, we have that minus 3 squared is 9. 4 minus 9. 4 minus 9 will give us a negative value, and square root of a negative value is not defined on R, so this won't work. Now if I pick a value between minus 2 and 2, let's say 0. Now if I put 0, you see that the value I have is defined because 4 minus 0 is 4, so square root of 4 is 2, so this is defined. Now if I pick a value between 2 and infinity, what do I have? 3. Now if I pick 3, I have that 3 squared is 9. 4 minus 9 can't give us any value, so you see that this is not defined. Remember, if it is true for 1, it's true for all of them between here. If it's not true for 1 here, it is not true for every other one between here. So our domain here is minus 2 to what? To 2. Remember, x is less than or equal to 2. Now let's check if 2 and minus 2 are included. Now if I put minus 2 here, I'll have 4, so 4 minus 4 is 0, which is included. Same thing goes with 2. So this is the domain for this function. Also, lastly, we have the last part, which says the lane function. The lane of x minus 2. Lane of x minus 2. Now lane is simply logarithm, and logarithm always works for a positive values. Okay, logarithm does not work for 0 and does not work for a negative value. Any negative value, it works for a positive value. So we set x minus 2 to be greater than, to be strictly greater than 0. So my x is strictly greater than what? 2. So drawing this, I have that this is 2, this is infinity, this is minus infinity. So this is strictly greater than 2, 2 not included. So if I put 2 here, so this will be 2 minus 2, 0. Lane of 0 is undefined. So if I put a value 3, 3 minus 2 is 1. Now lane of 1 is 0. So since it's true for 1 here, it is true for every other number. So we have 2 comma what? Infinity, where 2 is not what? Included. So that is the domain for the functions given. Thank you for watching this video. Please, I would like you to subscribe. Please watch this video and subscribe to this video. Thank you very much.